Hello all, welcome back to software maintenance lecture second. In this class, we are going to talk about software quality and we are going to see what actually is quality in use. Before going into software quality, we should know why we say a system is degrading, why a system is decaying over a time. So there are eight different parameters on which we can say, or the indicators based on which we can say a system degrades or a system decay starts. So basically, a system decay is a slow degradation process of software quality over time, and it uh, basically the response which we expect from the software, you're not going to get the same response after a certain period of time, which will eventually lead to the software becoming faulty, unusable, or maybe at that particular time it needs an upgrade. So the software does not actually degrades over here, but it rather suffers from lack of being responsive and updated with respect to the changing environment in which actually it is working. So let's see one by one. So we have identified this indicators into some subsections. So the first subsection is technical issues. So why? So very large component, overlay complex structure, and running in emulation mode are the three factors uh, which which comes under technical issues, and these three factors makes the system degrade. So with very large components over here refers to the development process during which the entire process gets the structural complexity of the large components during the operational state gets more complex. It means when we are designing some particular module, when we start writing the code, for example, when we start writing the code, it becomes very large, and it may happen like the source code is using third-party libraries, which after a certain period of time you may not get those support from those libraries, and during writing this code, the overall structure becomes very complex. That software after certain versions of changes, the overall structure becomes so complex that it is not possible for us to perform any more maintenance or any more upgrade in the software. And then we say, okay, now the software has come to a certain point from where we cannot upgrade, or where we cannot support the software. This software. The third factor, if you see over here, is running in emulation mode. This particularly happens when you design a particular software for for a system in which it is not being used. For example, a particular software which has been developed for running in uh, operating system of Windows, it may happen. It may not support or it may not work fully on Linux operating system. So these are the three different factors which we refer to as technical issues under software degradation. The next thing is management issue, which mainly focus on, which mainly happens due to high personal turnover and deficient documentation. So high personal turnover here refers to the recruitment and hiring and firing process. So during in software development company, you are going to see people come, people join, and people go away very fast. So it is not possible for and it is not possible for the software for software development process to have the same people who which same people you are going to find during the upgrade or during the maintenance process who have actually developed the software. This is because of the high personal turnover, which is a management issue, in which this may happen because of the salary. If a person is not getting, let's say, um, is not getting a particular sufficient number of bonus, or it may happen if he is not getting promotion, so he may leave the company. And in that, these all factors comes under this personal turnover. Deficient documentation, it may happen when during the development process the proper documentation was not followed during the entire process of SDLC. And because of this, maintaining a software or upgrading a software is very, very difficult. So it is expected that, like, whenever a maintenance or a software is being developed, each and every file, each and every changes or should be each and every process or changes, whatever is there in the software should be documented, because these two are the factors which comes under management issues. Third is quality issue. So software quality. So basically, software quality, we can define it as the ability of the software to function as per the requirement. So when we talk about software product, it must satisfy all the functionalities written down during software requirement process, SRS document, software requirement specification document. And this frequent failure, excessive resource requirement, different technologies in one system are these are the three different factors which comes under quality, which talks about quality issues. Frequent failures, it means whenever you are developing a particular software, it may happen um, uh, once the customer is using it, it may happen there are some functionality which was not captured during SRS. Now during the execution, there the customer wants to have those things added in the upgrade in the software. And when you are trying to upgrade the software, it may happen because of doing this upgrade, the other component may stop working, and at the finally when the customer is using the entire software again, it may happen different components are not working properly now because of new functionality we have added. So there are multiple other reasons why these frequent failures happen, but this is one example of frequent failures which comes under quality issue. And then is excessive resource requirement. It may happen when if you don't have the people who knows who knows who knows better about the project, then it may happen during the development process, you may demand for excessive resource. It may be in terms of human, it may be in terms of processing power, it may be any resource. So excessive resource requirement is also an indicator of system degradation. And the third quality issue happens if you are using different technologies in one system. It may have, for example, for the development software, the software which you have developed, it works on C programming language. It uses blockchain. It uses the concept of artificial intelligence, and then it may use embedded coding. So in these, whenever you are developing a software using multiple or different technologies, uh, then performing an upgrade or in the maintenance process, you are going to face challenge. And these are the indicators of quality issues, which is going to happen after a certain period of time. So software is going to degrade, and these three factors comes under quality issues. So now, if you see what we have learned from here is, so basically, whenever software system degrades, so it happens because of three different factors. The first is technical issues, which says old software tends to become bloated and full of less than ideal fixes to keep the system running. The second we saw was management issues. The process leaks, brains, and documentation is not properly maintained along with the system. And third is quality issues. The system performance gets weaker and the overall quality declines over time. So these are the three different parameters related to system degradation. Now, all these need to be addressed, but let's start first from the software quality. So like I said, software quality can be defined as the ability of the software to function as per the requirement. And the requirement over here is the SRS document. Now, what is quality? How can we measure quality? Now, the first factor is how can we measure quality? So when we can say that something has declined, uh, how we can say that something has declined too far? How can we define quality? Surely different project aim to different types of quality. So these are the two different questions which we have over here, and we need to address these two questions. But the thing is, how can we identify high quality? This is the first thing which we need to identify. So let's take an example. If we are taking 10 interviews, and if you're asking 10 different people, where you are going to expect 10 different answers. So it may happen even the people who are working on the same product do not come up with same definition of quality. Like I said, uh, so so the bottom line over here is there is no absolute high quality. The thing is we need to define and measure it one way or the another. So the quality we can so the thing is, can product with faulty design be of high quality? uh, we need to think about it. We have designed a product with a faulty design, and now we are trying to measure its quality on a scale, and we want to say, okay, so whether the quality of this product is good, or it's high, or it's low. So can product which keeps failing be high quality? So these are the two things which I think, in my opinion, if there is a faulty design and which keeps failing again and again, we that particular software will not have high quality. So so basically, the Garvin's definition of quality, he has given this definition of quality in various aspects, in different aspects. First is the transcendent definition. So it says quality is something that is intuitively understood but nearly impossible to communicate, such as beauty or love. The second definition is product based. Once the system has been developed and it is being used by the customer, in that aspect, in that position, we can say quality is found in the components and the functionality or the attributes of a product. User-based definition: if the customer is satisfied by the end of the by the software which you have delivered to him, the product has good quality. Then we also have manufacturing-based definition. So if the end product is designed according to the specification which was captured during SRS document, then we can say, okay, the software is having a good quality. And the next one is value-based definition. So we say if the product is perceived as providing good value for the price, it has good quality. Now, what is service versus product quality? So service quality is even more difficult to define than product quality, because for a particular product, if there is some service, if you are giving some service, it may happen that the other person may not get the same service which the first person has received for a particular product, and this often results from wide variation created by high customer involvement. So as the number of customers in a particular product are high, you may not expect the same kind of service quality for customers who for a product who are having less customers. And the example of this is a fountain pen and a food service. Fountain pen is a product which will be used by a customer, and the food service which totally depends on number of people who are going to deliver the food to you again and again. So what is quality cost? So investment level on, so this graph, if you see, total cost of quality is in the center. And so let's see this graph in this way. We have x-axis which talks about investment level on quality. We have y-axis which talks about total cost of maintaining and running software service. So if you see the blue line, as as the investment level on quality increases, so the cost of quality assurance is going to increase. However, with investment level of quality, cost of fixing things after a certain time of period, if you when you invest a lot of things on quality, cost of fixing things is going to decrease very sharply. And at the center of this graph, the dotted line, if you see there's a black curve which represent total cost of quality. So what is the total cost of quality? It is going to be sum of cost of quality assurance and this cost of fixing things. So the total cost of quality will always remain is going to be remain between these two margins. Now the next thing is we have quality. Now there are two different uh, models, or we can say we have two different models. Or uh, the first one is for measuring quality. The first one is system software product quality model, and the second is quality in use model or characteristics. So we are going to see first what is quality uh, characteristics of a product. So basically, the product quality. This graph or the chart which you are seeing on the screen. It talks about quality of the product. So the product quality model categorizes product quality properties into, if you see, eight characteristics: functional stability, functional suitability. Then we have performance, efficiency, compatibility, usability, reliability, security, maintainability, and portability. And of course, each characteristics is composed of set of related sub characteristics. So what this chart talks about. So once the product is delivered, if the product supports these characteristics, then we can say yes, the product is having a high quality. So in the functional suitability, it is a degree to which a product or a system provides function that meet stated and implied needs during the SRS, whatever you have captured. If the particular product is going to deliver you that those functionalities, then we can say the product supports functional suitability characteristics. Now, under this, we have functional completeness, functional correctness, and functional appropriateness. So, completeness means set of functions covers all specified tasks and user objectives. Then we have correctness. So, correctness means product or a system to which provide correct results with a needed degree of precision. Then we have functional appropriateness. So it is a degree to which functions facilitate the accomplishment of specified task and objective. Second thing is performance efficiency. So performance efficiency means it talks about performance related to the amount of resource used under a stated condition. And in performance, we are going to have time behavior, means it talks the degree to which the response and processing time and throughput rates are of a product is going to be analyzed, and it should be according to the SRS, and it should meet the requirements. Then we have uh, capacity, which talks about the degree to which the maximum limit of a product or a system parameter must meet the requirement. Then, of course, we have resource utilization. It is a degree to which a particular software uses the specific amount of resource which was mentioned during the development of the software. It should not demand more resource during the actual usage. So if these three parameters, these sub characteristics talks about performance efficiency. Then we have compatibility. So compatibility over here refers to the system should be compatible with the with should be compatible with the environment in which it is being executed, or it is being used by the customer. And in compatibility, we have coexistence and interoperability. Interoperability means product should work with different should be compatible with a different service provider, and so on. Coexistence means the product which is being developed, uh, it should be existing with it should exist with other products which are being used, and so on. We have different other parameters: usability, then we have reliability. So usability, it's a degree to which a product or a system can be used by specified users to achieve specified goals, with effectiveness, efficiency, and satisfaction. Then we have this reliability. So reliability is the degree to which a system, product, or component performs specified function under specified conditions or a specified period of time. Then we have security. So it is a degree to which a product or a system protects information and data, so that the person or other product or system have the degree of data access appropriate to their type and a level of authorization also. Then we have maintainability and we have portability. Maintainability refers to the degree to which a particular product can be maintained. It can be upgraded according to the new needs. Portability, it should the degree to which a particular product can be used in with multiple different operating system. Then it is portable. So these are the different 8 characteristics which talks about the product, actual software product quality. And if any product is satisfying these 8 characteristics, we can say, okay, so the product is having high quality. So what is the importance of different types of quality? Now, if you see, in all interviewed organization, every attribute which we have discussed in the previous slide is at least somewhat important. Only 9 out of 248 assessment, not this is a study which I am showing you on the screen. So out of 248 assessments, only it turns out that only 9 were in 9 interview we found that it was not important. So basically we can say it is being universally acknowledged that getting a good quality is a myth. And it totally depends, because these are the different factors, and it is very, very difficult to provide these different characteristics to the product once the product is delivered. And if it is very difficult to deliver or to support these functionalities, 8 functionalities. Then we also have the other ISO IEC 25010 model, which talks about quality in use characteristics. So quality in use basically is the degree to which a product or a system can be used by specific users, maybe to meet their needs to achieve a specific goal, and with effectiveness, efficiency, satisfaction, freedom from risk, and context coverage. So these are the 5 different characteristics which which when the product is being used, it should satisfy these five characteristics. I'm just going to tell you what these things are. I will not go in more detail about the sub characteristics. The effectiveness is the accuracy and completeness with which users can achieve the specified goal. Efficiency talks about the resources. and its relation to the accuracy and completeness with which users achieve goals. Then we have satisfaction. It is the degree to which user needs are satisfied when a product or a system is used in a specified context. Uh, then we have freedom from risk. So, a product or a system should mitigate the potential risk to economic status, human life, health, or the environment. So, these are the other risks which it should be free from. Then we have finally we have context coverage. So, it talks about the product or a system can be used with effectiveness, efficiency, freedom from risk, and satisfaction in specified context of use and in context beyond those initially explicitly identified. So these are the five different characteristics which comes under quality in a use model. So what this ISO IC 25010 actually measures. So basically, there are three different quality models called product quality model, which we saw just now, which has 8 characteristics. Then we have quality in use model, which have 5 characteristics. This one, and of course, we also have one data quality model, which I'm going to leave this for you, which is 25012. So you can just check what is ISO IEC 25012 data quality model, and we keep these three different quality different models. One talk about the product, the other talks about the data, and finally we talk about the quality in use, the actual use. So these three different quality models, if you see, are going to measure few things. So the black arrow talks about what actually is measured, and the dotted arrow, if you see, it talks about what actually is going to influence quality in use. So product quality model is going to measure the target software and the target computer system in which it is going to function. The data quality model is going to measure the target data on which it is going to work. It may be some customer's data about his health. For example, in healthcare, it can be the customer card number. It can be the customer's address, customer disease, his name, his postal code, and everything related to the customer. So these are going to come under the data, the target data. And if you see quality in use model, it is going to target the whole human computer system, the relation between the computer and the human system. So the whole system and the interaction with the human is going to be measured by the quality in use model. However, there are different factors which are going to influence the quality in use model. If you see from the left, it is the information system, the target computer system, the target software, target data, usage environment, primary, secondary, or indirect users. So these are all different factors which are going to affect the quality in use model, because it may happen. For example, it may happen the product has been developed for Windows operating system, but by the end, after a certain time period, it is now being used by in a Linux operating system, and the usage environment has been changed. So by the end, it can happen the software product may not support, or it may not provide you all functionalities as it was providing you when it was being used by in the context of Windows operating system. So this is a typical example how you can calculate time efficiency and cost effectiveness of a model. And this is something which I'm going to leave for you as a task. You can check how actually we can calculate time efficiency when we have the formula X, which is time efficiency, is equal to A divided by T, where A talks about number of objectives achieved, and of course T is the time. Similarly, we have cost effectiveness, and these, which is also X is equal to A divided by B, where A is the total cost of carrying out a task, and B is the number of objectives achieved. So these are the two different methods which measures user performance and is being used for measuring time and cost effectiveness, efficiency and cost effectiveness. So now let's see what is software quality practical view. So we have seen this SDLC life cycle in the first slide, uh, in which we now know requirement analysis, specification, design, development, quality assurance, uh, acceptance, and operations. This six phase comes under software engineering methods and model. However, software maintenance talks about uh, the last two stage, which is maintenance and end of support. Means we cannot we cannot provide more support to the particular software. So we have different quality themes. For example, quality is a conformation to specification. Whatever quality, like I said, quality should be quality can be measured. The software which you are going to deliver to the customer, it should be according to the SRS document, and it should conform to those specification. So the basic idea is get the specification right and build according to them, basis of the waterfall approach of to software development. But the question is, can this be done always? So this is possibly this is a discussion topic in which we should know during the development process, getting the right specification from the users and giving your own input based on your experience. You can design a software, you can always document everything, and you can follow the basic waterfall model. But in many cases, I think it will not be possible, because sometimes you have to deliver a software in a very short period of time, and there are other conditions also. Maybe the software company have a less number of people over there, and doing all processes, all process of waterfall model, because in waterfall model it requires a very big documentation task. It has very big documentation task, and doing this thing is very difficult. So you cannot, second thing is, you cannot inspect quality into product. It must be built in from the start. So you cannot say once the product is delivered, you are going to put quality into it. So it is going to come when the actual process starts from capturing the user requirement till the last phase, which is acceptance and operations. So inspecting or testing finds what is wrong with the product, which then has to be reworked. Too late. For developer, it's your job to make sure that what is passed on to testing team or another developer is of high quality. Testing ensures the potential, design defines the potential. So yes, testing is very important when the product is being developed, because after the testing, the product is going to be delivered to the customer, and he's going to use it. So this phase is very crucial for the product which is being developed for the user. And in many cases, we are going to see the most problems are the result of the system or process. You cannot blame the developers or the workers who are involved in it. It is the management problem. For example, consider we have a team of 5 developers in which we have 4 experienced people and 1 is new. The new one is in charge of keeping the specification up to date. What could go wrong here? So this is a simple question I have for you. Now you should now just think about it when you are placed in a group which already have 4 experienced person, and you have just joined that group um, as an maybe as an early developer, and now you have given the specification, you are the task to make it the specification task up to date or to capture the specification. then what tasks can go wrong over here? Similarly, quality is fitness for use. Workers must be empowered by support of top management. So these are different quality themes which we have. Now let's talk about key developer practices. So the two key developer practices that support quality outcomes are version control and of course testing. We are going to see these two factors which are very important in the next slides. So what is version control and best practices? So version control means once the software has been developed and delivered to the customer, after a certain period of time, you want to upgrade that particular software, and it may happen. For example, XYZ 1.0. Now the next version comes is which is going to be delivered to the customer is 1.1. So you have added some functionality, or maybe you have changed some functionalities in the existing software product, and now you are going to deliver this product, the newer one, to the customer. So what is the best practices whenever you are doing whenever you are doing this version changes? So complete one change at a time and commit it. So you just need to complete one change at a time. Don't do all changes at one go, and just commit it. If you're committing several changes together, you cannot redo them individually. So this is very important. So always you need to follow one change at a time. Doing multiple tasks or multiple changes in one go will make your work more difficult. And if you don't commit and your hard disk crashes, then whatever you have written down or whatever coding you have done will all go. So this is very important. So whenever you write, whenever you do, whenever you do some changes, always commit so that because of hard disk crash or some other environmental effects, the version which you have the technical things which you have changed should not go away. The second point is don't break the system build. So you don't have to. So basically, you need to test the changes before committing. So whatever changes you think you have done, and it is accurate for the product, don't commit as it is. Just check first. You need to test and then commit. So write the changes, test and commit. This is the process which this is the best practice which you should follow. And always commit the source file. The source file is the most important thing because it takes a lot of time to develop a particular source code. And always use the log by writing a summary for each commit. What has been changed and why? Because this is very important, because sometimes it happens whenever you are referring your own code, you may not understand, or it may take some time period to understand what and why you have done these changes. And of course, for other person who was not involved in this development, it will be very easy for him to understand, okay, so what actually this change means over here. Communicate with the other developers. This is very important. So if you are doing some other changes in a group, you need to tell them what changes you have done. This can be done by the means of documentation, by putting some comments over there, and by also you see. And the other thing is, you can see who else is working on part for changing it. It may happen this particular task was assigned to someone else, but now due to some other factors, you are being assigned to do these changes. So you need to talk to him what actually was done, or it may happen who else is working with you on the same module. uh, and the second thing is, you need to discuss and agree on a design. Don't just start randomly. You need to start. So you need to discuss and agree on a particular design. Then, of course, you need to follow the project guidelines and specification. You cannot do the changes by your own. There will be some guidelines of the changes, and they are going to be the software is going to be have some specification according to which you need to do the guidelines, because by the end the product is going to be used in a specific environment, and the product which like by the end it requires more RAM, or maybe more different processors. So the it should follow the project guidelines and specification. So this is best practices for an agile developer. For example, integrate early, integrate often, keep your project releasable at all time, automate acceptance testing, use automated unit test, write code in short, emphasize collective ownership of code, keep a solution log, keep it smile, don't fall for the quick hack, write code to be clear, not clever. Warnings are really errors, providing user useful error messages, be a mentor, share code only when it's ready, review code, keep others informed of the status of your work. So all these things, I think you know about these best practices whenever you are doing the actual development part.